Dear ladies and gentlemen, welcome again to our webinar about lithium-ion module and the pack production. This is session number 3, and today I'm here in our development center. We will talk in a few minutes. We will present you more about our development center, and I'm supported again by René today.
Hello, also a warm welcome from my side. I'm from the R&D department and will guide you today through the technical details.
My name is Stefan, and I'm the first contact point for you for all questions related to equipment for lithium-ion batteries. Most of you know us already. BM-Rosendahl is an equipment supplier coming from the lead acid industry, and now since 7-8 years already active in the equipment for the production of lithium-ion batteries in the segment of modules and packs. If you have any questions, please contact me. You will get my contact details at the end of this session. Brief view back into session number 1 and 2. In the first session, we were talking about the cell preparation. So how come from the single cells to tested and prepared cells into a loose stack. Then in the second webinar, we have been talking how to fix a stack together in any kind of framework. Mainly here we brought the example of prismatic cells. Either they are in a fixed metal frame or in what is now coming or is very strong on the market, a strapped design without any fixed frame. And then there is the question in the next step now, how to connect your single cells and how to bring the energy from the single cells to your battery system. And the most common choice for this is, as you see here, to put busbars on the cells and to fix them with laser welding. Also here an example with a cylindric cell. So Rosendahl Nextrom is supporting you with all the development steps in the busbar welding process. Here you see our playground where we can support you. We have here in our development center a laser welding station number 1 with a 1.5 kilowatt single mode laser. Then we have here a robotic station in the center where we can do tests for the cell preparation and the stacking. In front of this station, you see our strapping unit that we presented last time. And today we are here in front of the laser welding station number 2, which is equipped with an 8 kilowatt multimode laser. So we have prepared a question for you. Which kind of connection method are you using or are you intending to use for your production? Is it screwing, any kind of bonding, laser bonding or ultrasonic bonding, resistance welding, laser welding, or any other technology? So please make one or more choices on this question. So thank you for your answers. And so here we are in front of our laser welding station number 2. Here we can make with you together feasibility studies. We can test your raw materials. We can even produce for you prototypes and small quantities of your product. And this equipment is one example that shows you that we provide you the complete development. the process know-how, not only in laser welding, and the complete machine development, including the automation, the safety equipment, and of course, the right choice of laser equipment. We have here a short video of this laser station number 2. So you see here an outside view, and this laser station is already prepared with a small, short transfer system. So it would be as, or it is already prepared as it would be integrated into a serial production line, automatic transfer of the module, in this case with 280 ampere hour prismatic cells fixed in a strap module, and with their busbars already on it, and you saw the clamping of this module, and then step by step the laser welding of the busbars with the clamping device to reach the zero gap. So here a top view of this short laser impact that you have on the busbars, and then your module is already finished. So, René, one question. Why is it exactly laser welding, which is the first choice in our industry?
It's a very good question. So let's come to talk about the benefits and the advantages. So we build machines for a controlled and a reproducible process to give our customers a very constant and good quality through the production of our machine. So the product benefits over battery modules, you want to keep the resistance over the whole module very low, and this makes an impact on the battery lifetime. So also if you have a thermal input, as a laser welding will be, so the thermal input must be very, very low, not to stress the battery chemistry inside your cells. So, and if the welding is done, the weld depth will be measured, and in the weld depth you have a comparison to high strength of the welding. So it's quite necessary to keep the weld depth very stable and to keep it over the whole module stable. So, and this is very sustainable and also a clean process, which is quite good for the product on the one hand side, and on the other hand side there are some technical advantages, like it's stable and repeatable, and you can put the energy very precise into the welding. So it's a non-contact tooling. The laser beam is a light beam, let's say, and this has no real issues when it comes to serial production. So the maintenance is very low, and the precision is in positioning and in the cycle time very short. So it's quite a lot of advantages that comes together with laser welding.
So we have a next question prepared for you. Are you already active in laser welding? Do you already have a know-how, or do you still need support? So we see that most of you still need support, but there are also some experts in our round today. Thank you for this answer.
So let's talk about the laser welding key factors. Here you see the machine behind us. So we have a laser source next to the machine, and through a laser light cable, the energy will be transmitted into the laser welding optics. And here mirrors project the laser beam down to the product. So this is the surface now for the busbar surface, and beneath this there is the terminals. And to have a very precise and good process, it's necessary to keep these two materials, so the busbar and the terminal, quite well together and press it down. We call it a clamping device to secure a zero gap. So then the heat and the laser can be transmitted very well, and the welding will be as it was developed. So other key factors are to keep the tolerances very small and to have a very clean and also material with no oxides on the surface, to have no defects during the welding. So, and another very important factor is to keep the focus position of the lens, as every lens has a focal distance. Also for my glasses, we have to we have to have the best welding distance. So to secure that the smallest point with the highest energy is in the right position for laser welding. So, and next to this, there can also be some secure gases to have a good welding quality. So now we have a short graphic to where you see the welding joint of an overlap welding. On the top, the busbar, and beneath the terminal. So we see also the weld depth and the cross section. The cross section is the area which is the connection for your electric transmission, and this area is in connection to the welding area which is allowed from the cell suppliers. So therefore the welding geometry can be lines, it can be circles, it can be spirals or anything else which fits to your specification on the product design and on the welding area of the battery cells. So further, we can do here in the laboratory also the specified resistance tests and thermocouples on busbar and beneath the terminal. So we can also do a lot of tests with sheets and also with dummy cells. And further, we can also have tensile force tests.
We have summarized in a simplified animation in a YouTube video for you all the steps of such a process parameter development. You can find the link to this YouTube video in this QR code here below on the right.
Okay, so let's talk about welding parameter development. So we divide this into sessions where we start at the beginning with metal sheets. So these are metal sheets in the same material and same material thicknesses as busbar and terminals have. Sheet material is quite cheap in comparison to dummy cells or real cells. So we can do a lot of tests very quickly. It's easy to analyze because the cutting is very easy. And so we go up from sheet metal over to dummy cells, which are empty, and then to real cells with clamping tools and real module size, where we can do then, as Stefan mentioned, do some small production of prototypes and some small batches of customer products. So, and for analysis, we can do tensile strength tests, as you see here, where we can have a look on if the welding is quite stable, and we have the broken in the heat affected zone. So this is a quite good result. And we do the resistance tests from beneath the welding up to the busbar, or even over the whole module. And with the thermocouples I showed before, we can also do the tests during the welding. So for this is easy to show. Now things which happen inside and also outside of the welding. So therefore we do macroscopic analysis, where we see spattons, holes, or also some porosities or cracks from outside. And we have also here a laboratory where we can do very deep insights on microscopic analysis, where we can measure the depth, the width, and we can also see if the welding area was reached and the impact into the terminal was quite as the specification was set up. So a last topic is process monitoring. Also here we have the possibility to do sensor measuring for the radiation of the laser welding with some sensors where we can detect spattons, pollutions, and also if the gaps are quite wide. Another process monitoring system is optical coherence tomography, where you can measure surfaces in pre or post position of the welding keyhole, or we can also measure into the keyhole itself to measure the weld depth during welding. So this is also inline process monitoring.
Well, thank you for these deep insights, René. Before we come to the questions and answers, there is a hint to our next webinar session. The webinar number 4 will be held on the topic of final assembly of your modules and packs, and with that also the necessary testing and end of line testing. And the date will be the 25th of September. I hope to see you there again. A link for registration will be out soon via our LinkedIn channel. And now it's time for the questions and answers. So please put your questions to the chat function. So there is a first question. First question: have you ever managed to weld 1060 0 in thickness, 0.6 millimeters, and 5052 H32 in thickness 2.5 millimeters in compliance with standard EN 15085?
Okay. So this is a quite detailed question on material combination, which is, let's say, not so common. So 1,000 to 5,000 and the thickness differences, I think it's a connection. It's not a full penetration. So maybe that's just the thickness of the full terminal, as we have in prismatic cells also terminals up to 3 or 4 millimeters. This is for, yeah, so this combination we didn't weld already, so it's quite hard to say anything about this exact combination. But if you have this question, just come by and let's try this with our technicians and our combination of machine and laboratory to find out how does it work.
So we would really be interested. This is one of the questions our engineers, our welding, metallurgical welding experts really like. Please bring such a task to us. Send this question over to me after this session, and we would be happy to discuss further steps with you and even invite you to do tests here together with us in our development center. Second questions, have you ever used or do you have any experience with Chinese laser suppliers?
So it's also a very good question, as the laser equipment was a long time a very expensive one. So we see that price drops from laser equipment happens. And of course, laser as physically must be laser light. In action, you have to have the situation, the material, and then you have to compare this if all laser sources react similarly. This is quite a good question for the future. Let's see how the experiences with these laser suppliers develop for the future.
To make it short, yes, we are collecting ourselves now the experience. We're doing tests with Chinese laser equipment, but there are many questions still to be answered before bringing them into a working system here in Europe or Western factory. Without cracks is a question. Without bubbles, we have a transparent weld on prismatic cells with a minimum penetration of 0.3 millimeter.
Without cracks, without bubbles.
It's a question mark.
It's quite hard to say this. So if there are cracks, if there are bubbles, so out of our developments, we see this as a challenge to find out where bubbles came from. So it can be some pollution on the surfaces of the materials, as I mentioned before. It can also be a material impact. So this is quite hard to say here, but of course, cracks and bubbles, they have an impact on the strength of the maximum force, which then have an impact on the stability of the laser welding and also on the resistance. So this is also a thing which is not easy to explain with in a few words, but yes, the penetration of 0.3 millimeters is not so deep in the material. And if there are bubbles as well, it's quite hard to reach high forces.
Tensile strength, for example,
strength.
mechanical stability. Yeah. So do you integrate in your system a position sensor for the beam?
So this means maybe the focus position. Yes, we have a system where you can test automatically where the focus position is, and other measurements for a stable and a good overview on the battery or on the laser assembly machine and the equipment. So this is a question on the equipment side, as I see.
And that's not a question. It's just a thank you for the question answers
okay.
number one. Thank you. You're welcome.
So,
well,
yeah.
In the meantime, we can tell you more. So we really, of course, our main business is to supply you with equipment, with correct equipment, including what you hear here, the process, not only only about laser welding, also all the other processes that are needed. But laser welding is really one of the key processes in battery production. And for that, we have our people, we have this development center with the laboratory, and we are regularly welcoming here people from all over the world of this upcoming battery industry, not only lithium ion, also sodium ion and other chemistries, and people coming here to make tests and verifications and parameter developments, like when you have complete new material combinations or difficult combinations of materials, what we heard, like, for example, in the first questions, you are invited to come to us and we will work together on a solution.
New questions?
Have you ever had an incident with fire?
So here in our laboratory, we are allowed to weld real cells. So we do the development first, as I explained, on sheet metal, also sometimes, if available, directly on dummy cells. And therefore, we know a lot about the welding situation. So we had no fire in the past, and of course we have an fire plan, or also our machines are prepared to bring out products very fast, and also our production lines are developed and engineered with automatic systems to bring battery modules out of the machine and to secure people and the surroundings.
And the equipment in a second step. So all our equipments here have installations, for example, an evacuation box where you could drop a suspicious or burning cell or module into, and control the water, the fire with water, for example, and bring with that evacuation box the material out of the development center in a safe way. Also, the welding stations here are equipped with a high fog system to control the fire for several minutes until the fire brigade would reach. Also, we already had our incident, so I know that sometimes the laser beam had already reached below the terminal. I know this, especially in development processes, cannot 100% be avoided, but luckily it was never a real fire that happened in our development center here. Do you prefer static clamping masks or flexible ones, for example, using high-speed robots with single mask?
Also a very good question. So it's an expert question, I would say. So in our back, as I showed before, we have a clamping situation, which is quite as a static on one hand side, but very flexible on the other hand side, as we can reduce the position, so we can change the positions from module to module and from cell to cell. So it's a very flexible, and we can also compensate with this machine tolerances in length. So, and the length tolerances on a module, for example, this one is with 13 cells, can be a few millimeters, and this is very necessary to be flexible. The question is maybe also if we use static masks over the whole module, or have single masks, and we have, let's say, everything.
Yeah, so we really adapt our solutions to the product and production situation of our customers.
So it's a topic for cycle time, let's say.
Exactly, and tolerances on the product as well.
Yeah.
The next question, we already touched this topic. Do you have implemented on the machine evacuation system in case of fire? So yes, I already mentioned that we can integrate the sensors in our stations, especially in the laser welding stations, but also others. Combine it then with automatic evacuation modes on the control system, evacuation boxes that can take the suspicious or burning equipment and to bring it to control the fire and bring the product out of the production is one solution, and also to combine stations with spray or high fog systems.
So the next question is it's a question on the laser equipment and on the laser source. So what about solutions on green and red laser light? So we have here lasers in the infrared, in the near infrared segment with wavelengths between 1030 and 1060 and 70. Green lasers are in the visible light wavelength area. So the question is here, if we have red laser experience on copper aluminum combination for busbar and terminal, I think. And yes, we have. So we did all these weldings also with infrared laser beams on aluminum, copper. Yeah, so there are some issues you have to have in mind. So material is quite. You have to have oxygen-free material on the copper side, and then you can reach good material or good weldings. So this is a development topic. Yeah.
So I see René is just starting. I see he's already getting more and more ideas what to talk about. So really, again, the invitation, contact us and come to us. And there we have many experts. René and his team would be happy to talk about your welding task together with you. Next question. Would you say you offer more flexible production or high volume solution? Maybe I can answer that, as we have this question very often. So the lithium ion and other related battery markets are still so segmented and different from case to case. So we offer both solutions. We offer you laboratory equipment for small scale production, also laser then with a very flexible positioning and clamping system, not optimized maybe for high speed production, short cycle time, and as the laser here in the background, already equipment which is optimized for high-speed production with short cycle time and continuously working on similar product designs then. Good. So I see we are already a little bit over our time. Thank you. Here you see my contact details, and well, hope to see you again in the webinar number 4 after the summer break. Have nice holidays.
Okay. Bye-bye.
Bye-bye.